Okay, hi everyone. Today we are looking at a question like this. Okay, as you can see over here, this is obviously a speed question, but we always have to ask ourselves whether if it's DST, meet up, or catch up. Okay, so later words we will identify. Okay, so let's start reading the first part of the sentence. Okay, it says that Eliza started cycling to school at 6:35 a.m. at a speed of 14 kilometers per hour. So from this sentence, I do not know whether if it's DST, meet up, or catch up. Okay, so what I'm going to do is I'm just going to draw a timeline first. Okay, I know that she is cycling to school. So she started, let's assume that she started from home. Okay, let's not assume whether she started from market or whatever. Okay, doesn't matter. Okay, so we know that Eliza, she is going to school and she started at 6:35 a.m. Okay, and she is going at a speed of 14 kilometers per hour. Okay, so once I'm done with this, I can move on to sentence number 2. It says that her brother Keith started 10 minutes later than her. So her brother Keith started at 6:45 a.m. Why 6:45 a.m.? Because 10 minutes later than her. Okay, so when Keith started at 6:45 a.m., where do you think Eliza is? Eliza has already traveled for 10 minutes. Eliza must be over here. Right. So if Eliza is over here, we can write down the time as 6:45 a.m. So what you need to do is quickly find out what is the distance from here to here. Understand? Because we know that the speed is 14 kilometers per hour. We know that the time is 10 minutes. You understand so far? We want to find distance. So since this is in minutes and this is in hours, we want to change 10 minutes to 1/6 hours. Make sense? So the distance will then now be S times T. Right? So S is 14 times T, which is 1/6. Okay, so 14 times 1/6, we know that the distance from this point to this point is actually what we say 21/3 kilometers. Okay, so this is the distance that Eliza has traveled. So we go on and we realize that they caught up at what time? At 7 a.m. Okay, so let's find out where is 7 a.m. 7 a.m. Let's assume that it's over here. So Eliza is over here. When I say caught up, now I know this is a CU question, a catch-up question. Okay, CU. Okay, now Eliza is over here, and what time is this? This will be 7 a.m. Do you agree so far? So we can actually find out, right, the distance traveled from this point to this point. What is the speed? I know that the speed for Eliza is still 14 kilometers per hour, correct? Okay, now then I want to also write down that the time is actually goes to 15 minutes. And if you're wondering what is 15 minutes, I want to always change that to hours. So we just change to 1/4 hour. Okay. A good way to remember is this. To change from 15 minutes to hours, you just have to divide by 60. Okay. Another way is, of course, you can draw a clock. Okay. 15 minutes is actually just 1/4. Can you see? 15 minutes is just 1/4 of the whole clock. Okay. So that's one thing that I teach some of my students. Now, I can actually quickly find out what is my distance. So same thing, S times T. S is 14, T is 1/4. When you do 14 times 1/4, you get to an answer of 3.5 kilometers. Okay, so this is the distance from this point to this point. Okay, now let's look at Keith. Where exactly is Keith? Keith is now here. All right, so is it 7 a.m. for Keith as well? Yes. Okay, now so what we want to do is we want to find Keith's what? Speed. Because I want to find Keith's speed, the question must be able to let me or help me to find my distance and my time. Okay, one thing for sure I have is already my time, isn't it? Why do I know my time? Because Keith started at 6:45, right? And Keith met at 7 a.m. So we want to find what or how much he has traveled from 6:45 to 7 a.m. My time is 15 minutes. You agree so far?
Yes, and we also need to
1/4 hours, We also need to, so I got my time, So what about my distance? Now, you realize that Eliza traveled from here to here. So both of them, and Keith, same thing, traveled from here to here. So both of them traveled the same distance. You understand what I'm saying? So the distance for Eliza is actually from what and what is actually this and this for Eliza, correct? Isn't it true to say that we can mirror image up and use the same distance for Keith? Okay, so the distance for Keith is 1/3 kilometers plus 3.5 kilometers, and you get to 5/6 kilometers. Okay, so this is the distance for both Keith and Eliza. Okay, I have T, I have D. Hey, I can find my S now, correct or not? So I can find my S, so I'm just going to write outside because I have no more space. So speed itself will be D over T. All right, so D will be 5 over 6 divided by the time, which is 1 over 4. Of course, you can press your calculator. All right, and then you realize that you will get to an answer of 23, 1 over 3. Since we are talking about speed, we have to put kilometers per hour. And the question says, at what speed the Keith cycle? So therefore, this is your answer for this question.